In this video, I will be discussing diffraction and Huygens construction for EDEXCEL. Specification point 83 states that we need to understand what is meant by diffraction and use Huygens construction to explain what happens to a wave when it meets a slit or an obstacle. By definition, diffraction is the process by which a beam of light or other system of waves is spread out as a result of passing through a narrow aperture or across an edge of an obstacle, typically accompanied by the interference between the waveforms produced. And Huygens construction states that every point on a wavefront may be considered a source of secondary spherical wavelets, which spread out in the forward direction at the same speed of the wave. The new wavefront is the tangential surface to all of these secondary wavelets. So I'll explain more about what that means in this next slide. Here we have a wavefront which is represented by the first line. And on that wavefront there are black dots, and those black dots are sources of secondary wavelets. Now these secondary wavelets interfere and produce a new wavefront. The new wavefront is the tangent to these secondary wavelets, which moves with the initial speed of the first wavefront. This is how a wave would propagate. So you have your first wavefront, sources of wavelets along that first wavefront that constructively interfere to produce a new wavefront. That new wavefront is then tangential to the surface of those secondary wavelets, which moves with the speed of the first wavefront. Now, in this slide, we can see that as the wavefronts approach the obstacle, there is obviously two yellow obstacles and a slit in the middle. Now, assuming that the opening or the slit is much smaller than the wavelength of the wave, we would see that as the wavefront reaches the two sections of the obstacle which has no opening, would result in either the reflection or absorption of the wave by the obstacle surface. The part of the obstacle which has the opening will partially allow the wavefront to pass through, and then the secondary wavelets will interfere constructively, resulting in a newly formed wavefront which is tangential to those wavelets. The ability for a wave to spread through a narrow gap or past the edge of an obstacle is known as diffraction. If the wavelength of the wave is the same size as the aperture/slit, you would get the most noticeable diffraction occurring. So what happens if a wave encounters an obstacle? The same idea applies. Let's take a barrier for example. As the wave approaches the barrier, you will get diffraction around the edges, resulting in the wavefront secondary wavelets to constructively interfere and form a new wavefront. If the object size was to be increased in comparison to the wavelength of the wave, less diffraction would occur and therefore form a longer shadow. You can test out this idea by holding your hand in front of a torch and moving your hand closer to the torch and seeing a larger shadow being produced. Thank you for watching this video. I hope this has made sense and cleared any questions that you may have had about diffraction, and I will see you later. Thank you and goodbye.